Okay, let us discuss this problem. This is from E Irodov. So let us say to draw the diagram and then we'll discuss the problem. So this is 1.234. So you just make the figure and then we go for the problem. Okay, let me read the problem. Have you written or not? Okay, so let us read. Okay, let me dictate. So you have a rod. Of course, this rod is a massless rod. No, not massless. Mass of rod is m. This is given to you. So mass of rod is m. So m is the mass of rod. Now the length of rod, let us say length of rod is L. Basically we have to find what is the length of rod. So to find length of rod, the Irodov is doing one experiment. What this experiment is, he is applying a force F1 here. He is applying another force F2 here. These two forces are in opposite direction. One force is at one end. Next force is not at end. So this is at a distance from here to here, that is distance A, that is given. Now there is a center of mass since the uniform rod. So I can assume the center of mass lies at a distance of L by 2 from this end and L by 2 from this end. Now F2 is given. F2 is given in the problem, but F1 is not given. So F1 is unknown, F2 is given. And Irodov says the acceleration of rod is omega. So this is it. So given. Let us say generally he does not use omega, but he is using omega. So omega is the acceleration of this rod. Basically he uses W sign. So let us assume W is the acceleration of rod. Rod is uniform. Mass of rod is m. Distance AO is A. Now what we have to find is, we have to find what is the length of rod. And this says rod does not rotate. It simply translate. So one more information is given to you. Rod only translate, it does not rotate. If the rod is not rotating, you can apply all these ideas and you can solve this problem. So you will have, let me give you a hint. You will write one equation for translational motion and you will write one equation for rotational motion and you can solve for L. Because you can write two equations and two unknown, L and F1. So you can write two equations and there are two unknown, F1 is unknown and L is unknown, the length of rod is unknown. So you can always solve for two equations. So let us give you 2 minutes time and I see how many of you are able to solve. And once again I will give you a hint. Since rod is in rotational equilibrium, so total torque should be 0. Let us take torque about center of mass. You can take torque about any point basically. Let us take torque about center of mass. It has to be 0. Now you write them to total motion along this direction. That is force is equal to mass into acceleration. So write down the total force in this direction. Equate that is mass into omega or W, whatever this is. And solve this equation, you will get the answer. Now everything is done. Let us take 2 minute time. Okay, let us discuss the solution. Maybe some of you are able to discuss. So you see, let us make this kind of diagram, you see. So I will have, this is my center of mass is here. So this distance is L by 2. If the total length of rod is L, so this distance is L by 2. If this distance is A, then I can say this distance is L by 2 minus A. Now if I take torque about center of mass, so taking torque about center of mass, total torque has to be 0 because this is in rotational equilibrium. So this means torque this side is equal to torque this side. So the torque of F2 is F2 into L by 2A. This is this side. Torque of F1 is F1 into L by 2. This is this side. So torque this side is equals to torque this side. So you see, I can write F1 into L by 2 is equals to F2 into L by 2 minus A. Now if you expand this one, F1 into L by 2 is equals to F2 into L by 2 minus F2A. Now you take L by 2 common, you can have this. You can solve for L, you will have this. So you will solve for L, you will get this equation. So let us solve yourself. Are you getting this or not? So from here, you can go here. So let me wait for some time. How many of you are able to solve this one? Solve for L. Done? Are you able to or not? So are you able to get L is equals to 2F2A but divided by F2 minus F1? All of you are able to get or not? Okay, good. So all of you are able to get. So let us go to the translational equation. So if I write equation of motion for center of mass, the total force in this direction, so this is my x direction, let us say F2 minus F1. So total force is F2 minus F1. So mass is equals to mass into acceleration. So let us say acceleration in this direction is W. So m into W. So from here I can find F2 is nothing but F1 plus mW, or I can directly put this value of F2 minus F1 here. So you see, because F2 is known, so this is known. If I plug the value of F2 minus F1 here, so what is the value of F2 minus F1? That is m omega or mW. So you see here, F2 minus F1 is mW. If I plug this value F2 minus F1, that is mW. So L will become 2F2A divided by m into W. So this is the total length, because F2 is known, A is known, m is known, W is known. So now I know what is the length of the rod. Now if I put the value of F2, value of L in any one of the equation, so let us say in this equation, I can get, I think if you put this value of L here, I can get the value of F1 also. Are you getting or not? So if we plug the value of L here, I can calculate what is the value of F1. Are you getting? So if I want to find out the value of F1, if I plug the value of L here, and then I can solve for F1. Are you getting? Okay, good. So this is a fairly easy problem. So what we have done is, we have written two equations of motion, rotational and translational, and we know there are two unknown. W is known to F1 as well as length of rod is unknown. So I have two equations, one for rotational, another for translational. I can always solve for L. I can always solve for F1. That I am doing, nothing else. So simple. Now we'll go for the next problem. Have you written, have you understood any misconception? No misconception. Good. So easy problem. We'll go for the next problem. So what we have learned from this problem? We have learned in any problem that does not have rotational motion, torque is equals to 0. That is one point. What is the next point we have learned? We have learned that sometime I can even found the unknown that is not obvious. So now you see in this case, length seems to be a known thing, but in this case I can find length also, F1 also. So even if I apply forces, different forces, and if the rotation of rod is 0, I can calculate L. I can calculate F1. What is the force I should apply? What is the force F1 that I should apply? So we can calculate L and F1. Okay, we'll go for the next problem.